So, hello, gentlemen, and welcome in this panel discussion. Thank you for coming. The topic will be Frontier Among Regulation and Innovation. And first, I would like to introduce each of these lovely gentlemen by presenting short bio, and then I will have 3 quick questions. And then we will open discussion for this topic because we have here representatives of the regulatory sector, of the company sector, and of the cluster organization. So we hope that you will have nice insights from this discussion and we will have a fruitful conversation and very interesting insights. So I will start from my left, Peter Grambow. Peter Grambow graduated from a Max Planck Institute where he later worked and set up a clean room laboratory for fabrication of microstructures. Throughout his career, he was operating also at various management positions as a director of hardware development, team leader, head of product engineering, and so on. Since April, Dr. Grambow is a member of the management board of the Bavarian Cluster Nanotechnology with the main objective to maintain and further develop nanotechnology competence and network for an efficient transfer of R&D results into practice. So welcome, Peter. And then following by Mr. Kůs. Mr. Kůs graduated from electrical engineering and also sociology and psychology. He worked over 20 years in industrial automation. He founded the company Nanospace, which was the first company manufacturing anti-dust mite nanofiber bedding. He is quite popularizer of nanotechnology and of the concept of third industrial revolution and sharing society. Currently, he is the president of the Czech Nanotechnology Industries Association, whose establishment he initiated. Hello, George. Nice to have you here. And Mr. Koltsov, who is representing the regulatory sector here. Well, company and the regulatory sector. He's not our enemy, of course, he's our friend. So he graduated from Cambridge University, where he obtained his PhD, and he worked as a research associate in Cambridge Nanoscience Center before taking up a lecturing position at Lancaster, where he led the nanotechnology work and outreach services till 2009. He's now running his own consulting practice, Break Solution, that focuses on technological, regulatory, and standardization issues of nanotechnology innovations. He's expert representing various committees such as BCI, ISO, ISCCN, and currently he holds the chairman of the ISO TC 229 position in nanotechnologies. So welcome, Denis, and nice to have you here. Let me start with the short questions. I would like each of you to make a short presentation of the companies or associations that you are representing, and then we will go directly for the topic discussion. So, Peter, the question is yours. You are CEO of the Nanotechnology Cluster Organizations. Can you give us more insights about your job and the organization by itself?
Yeah, of course, I like to do so, but first of all, I like to thank the organizers to invite me to this very nice place here. I have never been before here in Liberec, and I'm deeply impressed what's going on here in terms of research, but also in terms of production. So thank you, Thomas, and thank you, David. You're really nice guys and supported me especially a lot to be able to come here. About our organization, we are more or less both. We are organized as an association and as a company. And the main goal from the company is to earn money, simply to earn money. We are roughly 10 people. And what we are doing is somehow the same thing you do. Building bridges is very important. Doing that means you need to translate often from one world to the other, from the research people to the production guys, or you know what I'm talking about. And I think you all know what I'm talking about, because this is not only complicated, it's a lot of fun to talk to people in these worlds and get an idea how they think and how to be able to work together and to combine these worlds. And our strategy is to do it in the following way, because as you all know, nanotechnology is a broad technology. It's a cross-sectional technology. So you are lost if you do not focus on specific topics. And this is what we did since 2007. we set up or we implement networks, and the first two networks we started with were material-oriented networks. So it's about nanosilver and about nanocarbon. And nanocarbon is interesting because in the meantime, this is our most international network. And this is interesting because all over the world, people uses graphene and especially CNTs, carbon nanotubes, more and more. And this is very important for the nano world, if you want to put it that way, because, as you might know, it's the CNTs, multiple CNTs are used to improve the performance of the electrodes of lithium-ion batteries. And this is interesting because now you have production facilities with 6,000 tons per year for multiple carbon nanotubes. And that means the price is decreasing. And this is good news for other industries to use CNTs. So let me proceed with the other networks, but I don't want to be too long, but we set up networks for analytics and characterization, because otherwise you are lost. You have to know what's going on in this nano world, as we learned today. And then we decided to enter specific industries, like the nano ink industry or geothermal energy, which is quite interested to use nanoparticles there. And the last two sentences about the association. We think, and I've learned it today, not only we, education is very important. And the children from today, they are our future. So we are going into schools and do experiments, not only PowerPoints, real experiments, sometimes they work, with nanotechnology. And this is the idea, to motivate young people to study math, to study physics and chemistry and whatever.
Thank you very much for the introduction. Also, how about the political ecosystem, the policymakers and the supporting organizations? Which kind of support do they give you in this way?
Yeah, we started in 2007 with a support of 100%. And the support comes from the Bavarian ministry. Now we earn our money by ourselves, roughly 85% of the whole budget, and still we get some money from the Bavarian government. So this is one story. The other story is, what do they expect? And in this case, the answer is easy. They expect that we spread nanotechnologies not only in Bavaria, in Germany, and of course worldwide. That's very important. Therefore, we have a very good cooperation with the Czech guys here since 4 years, 1.5 years, or something like that. This is important. You have to do so, and they realize that. But talking in general about money for innovation, this is not that easy to get it. Because what they expect is more and more. And the expectation is, you have to realize it in 2 weeks or in 1 year. And today we learned Moore's law. I think it's 55 years old. 55 years. And the invention here, 20 years. And then you can build machines.
Yeah, it's the same here. It took 12 years to develop something, or 20. Yeah. So it's for long term. Thank you very much. George, you are the captain of the Czech Industries Association, Nano Industries Association. So tell us a bit about your association, and if you can tell us how the world perceives the Czech nanotechnology sector, and which are the challenges that your companies face in the internationalization. Thank you.
Maybe because in the morning I had the presentation of the associations and what we did. And so briefly, we are a group of companies, we are 39, and each of our members is either manufacturing products using nanotechnology or using nanomaterials. And we are lobbying and promoting nanotechnology. Because the topic we should discuss is where is the frontier between the regulation, safety, and innovation. I would use as a bridge to take us back to the topic one of your sentences. one of your words, education. Because if you understand, if you learn, if you are educated, there is a lesser space to be manipulated by somebody. Oh, it can be dangerous. And also what we are doing in our association, I think you are doing the same. We are making from invisible something understandable and visible. Because you mentioned that I studied also psychology, and you know, when we meet something which is, when we meet something for the first time which is invisible, strange, we are scared. And that's okay, because we should be scared from something new, because you never know if it's good for you or bad for you. So it's a good mechanism. But regarding the innovation, nanotechnologies, they may be strange and very small and so on, but they can help, do a lot. And it doesn't mean they must be dangerous. It must be dangerous. So this is what we are doing in the association. We are promoting a lot, explaining, showing, look, this is the product, it's making this. So this is what we do. Okay, so.
Yeah. So Denis, you have really great track records in the field of standardization, regulations, and so on. Can you briefly tell us about your job and about how nanotechnologies are regulated? I know that this topic can be discussed for 20 hours, but just, try to be quite brief, separate what's going on at the EU level and what is helping the companies in this sense.
All right. Well, first of all, I need to sort of distinguish between standards and regulation. Standards are quite often voluntary. So you may or may not follow it, but if you feel like it adds value to your business or to your material, to your product, you obviously follow that. Regulation is compulsory, and it's either national or regional based. For nanotechnology, I know a lot of people say that there is not enough regulation. I am in contact with European regulators from ECHA and European Commission. I'm also in contact with the overall global regulation for nanomaterials, which is done at the OECD level, which is the Organization for Economic Development and Cooperation, based in Paris. I have a seat there as chair of the ISO committee. They gave me a permanent seat there. They discuss all the guidelines on how to test a particular nanomaterial, fibers included. So they test in various ways. There are lots of ways to make sure that your material is safe, and that is the main concern. Now we have to take this with a pinch of salt because things do change, and we learn more and more every year about nanomaterials. Some of the nanomaterials are becoming proven not to be of any concern. And this is quite interesting that originally we set out thinking that most nanomaterials should be looked at because they are nanomaterials. But actually, after doing tests and not finding anything for 20 years, I think it's time to drop the mic and just go quiet. So there are lots of these conversations. I've been part of NanoDefine, NanoReg projects from European Commission. As you know, there are European regulatory definitions for nanomaterials. We can discuss that a bit further. They are a little bit different from the ISO definitions, which are not regulatory. I can also discuss that. But for nanomaterials to go forward, you have to realize that regulation is the one that's actually sort of holding back a little bit the innovation, because it tells you what not to do. Which is fine to take the materials forward in a safe way. But in some countries, we have seen that, for example, a head of Italian delegation talked to me over one of the meetings, and he said, Dennis, I've looked at most Italian European projects, the victories, they secured some funding. Most of those projects are actually in compliance or regulatory work. They're not moving the innovation forward. This is basically sort of standing and walking on the same spot, because yes, you're making things safer, but where is this movement forward? And this is where my concern is. Where do we add value? Where do we move the European industry forward? Because other countries moving forward from going not too far, but you know, US, Canada, China, just to say a few words, they have lesser regulation. They have different regulation, but less strict. So it's very important to stay in the global context.
George, you want to something add to this?
No, I have in my head the German nano dialogue. Peter can tell us more. I participated in June, I think it was in Berlin this year, the conference which was organized by the Ministry of Environment, or German Ministry of Environment. And it was about nano dialogue, which is in fact the dialogue if nano is material safety or not. And there was one guy, maybe you know him, who raised the hand and tell, you are 7 years, you are studying, and you are telling us we have not yet enough data. You made a pile of information, a pile of your ignorance. So please tell me when you will have enough data, which is what we are taking. Maybe Peter, if you can.
Actually, it is a very big issue, especially with when you are, for example, a national regulator. You have to take things seriously because you are ultimately responsible for the whole country's regulation. So quite often, what you get is academic publications which could be quite speculative, and they may not be as robust as you would like. So with the OECD, for example, for some time, at the beginning especially, there was this information deficiency model where people say, oh, we don't have enough information, give us more money. And thus, this was literally those words.
So they are telling the money is going to the circle we are collecting data about safety.
Yeah, but the problem is that the data is not really collected in a consistent way. So there's no agreement on how to collect it, from what materials. But OECD has done some order in this. There were NanoReg 2. It's gone in a good direction, but they have consumed a lot of funding. For this.
How do they divide the nanomaterials? Because I heard that there will be some groups of nanomaterials. Because, for instance, nanofibers are infinite, so they have only one dimension in the nanoscale. So they are completely safe, in my opinion, and they still are regulated, right? Or
we go to Peter. Your comment.
Just 2 sentences. The name of the guy is Professor Harald Krug, and he was a researcher in toxicology. And he found out the idea was to get an overview about all the papers in the world, more or less. And the fun fact was somehow that only 10% are valid. Mm-hmm. The other 90% are rubbish. And he said that in his paper. And you can imagine what the reaction was. Mm-hmm. But he was a very nice researcher working from Switzerland. And he really proved that this was the case. Mm. And so you can imagine what the landscape is. And so it's more or less somehow easy if you have the money and if you have enough time, but nobody has that. And especially if you want to do innovation, then this is a problem.
Exactly. It's important to say that we are not against safety. No, the issue is not let's forget safety and let's do any kind of innovation, but I start something, I study safety, and at the moment I say, okay, it seems that should be okay, I go further. Because if you are stopped and years you study, so you spend money for endless testing, and the other world is running.
And there are no products on the markets, right?
Until it's late.
Excuse me. I completely agree, and this is really important to know. From the beginning on, in our case, we always have not only the discussion about chances, but also about risks. Where are the possible risks and so on? And you have, of course, to do something, and you can do something. So from my point of view, this new discussion, safe and sustainable by design, is helpful to think from the beginning on about recycling, about what can you do in 10 years and so. This is a good idea, but hopefully it's not too, how should I put it? I ask your guys the question, what can I do as a small and medium enterprise to do it, to fulfill all the rules? Right. And the answer was, okay, maybe you can support us to do so.
Okay. What we find is that there's quite a big difference between large players and SMEs or startups. Large players, they have their own teams of people who make sure that the new developments are answering all sorts of standards, all sorts of internal regulations for the company. You take large, big, like Evonik or BASF, or they have their own procedures that answer all those questions. Small companies or startups have none of that. You're basically starting from a blank sheet of paper, and then you have to make it up as you go along. And in this case, safety by design, I think it tries to, but it's extremely tough problem to sort of cater for all sectors and all applications, but have the philosophy of the design that you need to implement from the start, that, for example, your material will be safe while producing to your workers, safe while being used by the customer, and also safely disposed of or utilized or recycled at the end of life. And this is a tough one, because you can see that the whole path of the product goes through, but it also takes into account the research stage, because at the research stage nobody knows what's going to be at the end. Right. And you don't even know whether that material will end up being a risk factor or anything. So you have to be cautious, but I have lots of arguments with the European Commission, for example, on the implementation of precautionary principle. I don't know if you've heard of this. The precautionary principle basically tells you that you don't go if you don't know. But that means that you have no way to innovate. You basically, even crossing the road has a risk of you being knocked off. Well, are you going to stay at home? So in a sense, innovation is in a complete clash with the concept of a precautionary principle, while precautionary principle is written in constitutions of several European countries already. So we have this issue. And standards, through the process of actually detailing all the steps you need to take to your best knowledge at the time, standards actually allow you to say, look, I'm honest, I'm doing everything I can. Tomorrow may change because somebody may discover something else, in which case I will change my approach. But today, I'm doing everything I can to make sure that my product is not only safe for the users, but for my workforce, for the disposal company people, for all of this chain of command. And I think this is quite useful. This is I believe, is one of the greatest added value from the actual standards. It's not a regulation, you don't have to follow it. Safety by design is not written in regulation, but we are working on this at the European level.
So if, for instance, some company has some new invention, how do they proceed? They must study everything, or they just, contact the commission, or what's the easiest way to test the safety?
There are safety tests for various products. It depends on what the product is. Of course, if it is a solid, you have certain steps to show that maybe it's a solid plastic with carbon nanotubes or graphene. You need to make sure it doesn't leach out during the use, etc. So that's one of those things. If it's a powder or a sort of some sort of dispersion, there are other tests. There are also sectorial tests, sectorial differences. So food and drink, they're very strict. Cosmetics, less strict. Drugs and medical devices, they're also different. So all of this needs, they're all governed by different directives in the European Union. But globally, there are also national regulations for many countries.
Okay. Do you want to add something to this?
This one, you mentioned the definition of nanomaterial.
Oh dear.
Which is a large chapter. But in my opinion, so everything which is under 1 micrometer is nano, right? But we shouldn't say nanomaterial is that, but we should say, okay, between 0 and 100 nanometers, we should be more careful, or we should go plus this 50% of, but not to say between 100 nanometers and 1 micrometer, it is not nanomaterial. It is, but it's not about, it's such a play, in my opinion, it's silly play.
I have to give some historical context to this. 1 to 100 nanometers, this is nanoscale. And it came about when it was all invented and started a long time ago, because chemists, they work below 1 nanometer. So people said, no, we are not part of chemistry. We're something similar, something different. And we're not part of microtechnology, which was from micron onwards. So they took 2 decades from 1 nanometer to 100 nanometer, completely arbitrarily. There was no reason for choosing that. They chose that.
Yeah.
Okay, that was before I even started my professional life. Okay,
not guilty.
Don't throw anything at me, please. The ISO defined it as such, and we know, for example, for toxicity tests, some of the nanoparticles of 200, 300 nanometers, they are more active in terms of perturbing or changing the functionality of the cells than the small particles of, say, 50 or 100 nanometers. Right. Because those, they diffuse in and out without altering any processes. So this 1 to 100 is neither here nor there. The European definition of nanomaterials took that and then expanded into a more regulatory approach, because then you have to qualify it by how much of the material of that kind you have. Because most powders, they would contain a lot more of other stuff that is big. But then by number, you have to say, okay, well, I have 50% of particles between 1 and 100 nanometers. Problem is that if you go on the beach and you collect sand, you'll have lots of very big particles.
Dennis, there's also one thing, because...
But then you have very small particles and you will qualify your sand as nanomaterial.
That's spent, and also the percentage. I remember again the Berlin, so I was very impressed in Berlin by the discussion. There was somebody from Canada, they have 40% and Europe has 50%. And I don't know if this was Professor Kruger, somebody said, okay, so you have 50%, you have 40%, so... Right.
Maybe I try to give a more practical answer. What we did in one of our projects, it's about the usage of geothermal energy. And how can you do that? You use polyethylene and you dissolve CNTs in this polyethylene, and you do that to get a better conductivity. And this is possible, and we showed that on a kind of demonstrator. And on the other hand, we did a feasibility study for 9 months with a company called NanoCzech. And they can do these, or they do have animal systems where they check, is there any danger for the environment? And this is not easy to do so, but it's not the discussion, about how do you set the particles free. That comes afterwards. It's a discussion about, are the CNTs dissolved in water? Is that dangerous? And they measure it by the reproduction of these little animals. And the answer really was absolutely no danger if you feed them with pure CNTs. And I think this
cruel people.
This is really,
Dennis is another
But from my point of view, this is a good starting point. It's not the end, of course, but as you said, so we have to have an eye on it. We have to have an open discussion on that. That's very important, to be transparent. What are we doing, and what do we do not because it's too expensive and so
Can
on.
I just put a note here, because this is actually something very important. Over the years, we have not seen much negative result reporting in academia. In order to publish a paper, you have to have a positive result. So if you have CNTs and you have a biological system, you just put some CNTs in there, you increase the dose until that thing dies, and you go, that's it, we've got a result. But in many areas, people have tried this, and I've spoken to a few researchers, and they've done this, and nothing changed. So the thing still was okay, just like you said. But this was not publishable.
Carbon nanotubes.
Yeah, I had them in the breakfast. But, yeah.
So no, I mean, I wouldn't have them for breakfast, but but academics tend to report something that is sexy, speculative. They wouldn't report something that didn't happen or nothing happened. And therefore, we have a skewed distribution of effects in academic literature. That is, in addition to what you said, that most of those results are 10% accurate. So only 10% of those publications are accurate. So you see the problem we have. And if you have to make a serious decision on whether to introduce a new regulation or a reporting scheme in various countries, you have to be based on science, and the science is unfortunately not reliable here.
Yeah, so it's a cycle that is sometimes hard to broken, right? Yeah. Because, for instance, with some nanoparticles, there were many tests, thousands and thousands of studies that are not proving anything. So how do you perceive these kind of cases, that you end up...
It's, again, we are to that question, when will you have enough data?
The problem is that you can't prove negative. So if you are trying to do more tests to prove that this nanomaterial does not cause any problems, you're just asking the wrong question. So I think if you do full due diligence and you've done all the tests there are, you're basically de-risking your own position, and you're saying, look, I've done everything here. With that, we try to help in terms of the agreements at international level. You are openly saying that at this point in time, this material is safe to use.
From my point of view, one of the important questions is how to support SMEs in this question, and what can they do, and is there any visibility at the Commission or for the regulators?
Commission would not do anything. They're in the ivory tower. So most of the time, it's people like me who could get a phone call saying, "What can we do?" And then I will try to figure this out. As a consultant, I work with a lot of SMEs, large companies, even government agencies.
So do you see some, movement in the better direction, or you said at the beginning that it's improving? Hard question, right?
That's a hard question. I wasn't really thinking in that respect, because defining better is a difficult one. I think it's more established now. People are. I know at the beginning, maybe about 15 years ago, there was sort of very negative approach to the fact that European Commission was going to regulate hard on different aspects of nano. And some companies even left industry associations not to be affiliated with anything nano because they said, we're not doing nano. Not yours. Don't
I've heard.
But it was hurtful.
Maybe you're right. I've heard an opinion that now nanotechnology is no more so sexy for regulation. AI will be more sexy.
It's good that the light is going to another direction.
European Commission moved on. They've done nano, and now the new terms are advanced materials, or even advanced materials are not very well defined. We can have like a 3-day conversation on this. But there is also smart materials, which even European Commission doesn't know what they are, but they use this term already. So
Peter, you want to do
Yeah, we have to talk about quantum technologies. I'm just kidding, but this is the next important thing, yes?
Yeah.
And I mean, I do remember very well in 2010, some companies, as you mentioned, they said, no, we are not doing nano. Our particles are 200 nanometers in diameter, something like that.
Submicron.
I mean, this is completely nonsense.
Well, this is actually quite interesting. I actually had, as a consultant, I get lots of confidential inquiries. That was some time ago, so I'm not going to say who it was. But zinc oxide, powderous form, the user of this material openly told me that they don't want information from the supplier of that powder to give them full information, so that there's some sort of barrier of information tracking, so they would not lie to their consumers that this was nano. And at that point I said, I'm sorry, I can't do this. But they were scared of going into the nano, but it's a powder.
There was a time that everybody thought that nano is killing everybody, all the nanoparticles are able to kill us, and then it proved that to be nonsense, because nanoparticles, we are reading them every day. So.
Yeah, we know the term now is fake news, okay? So this was pretty much fake news. Let's not be complacent. There are some materials that do need attention.
Of course. No. Of course.
But there were a lot of fake scares.
Mm-hmm. So, gentlemen, I think we are... okay. So we have some space to have some questions from the audience. So if somebody would like to have questions to these gentlemen, just feel free. Okay. So thank you guys very much for this fruitful conversation. I think we had a great discussion. We understand that nanotechnology is not, dangerous at all.
You can eat.
And you can eat nanocarbon tubes for breakfast, of course.
Thank you.
I hope they don't serve that in our hotel.
I'm looking forward to in another opportunity to discuss with you. Thank you.
Thank you.
Thank you.